Okay, so closing remarks. Let me start with a quick demo. We don't have a lot of time. We have 15 minutes. I want to make the most of it. I already lost some of you, even though many of you are still here. So there is this PyPy package downloads. It's like all the downloads we got for Python packages using like pip install and stuff. And I want to build a nice interface like this. This is public. This is powered by ClickHouse. You can access, you can play with it. You can do like click here, for example, and just use the playground to change the queries, write your own queries, and just do a few things. Okay. And this is a UI. I want every time that I refresh to get new data and for it to be rendered like this, right? So how do we get here? Not using BigQuery. If I do a refresh and it takes 6 seconds to get one of those queries, or even 6 seconds to all of them, that's not going to work out. So that's when real-time analytics shine. So let's go. I have a very simple query. Select count star from BigQuery file downloads. And I executed this query earlier today, and I can execute it again if you don't believe me, so just put it in chat. But it took 4 minutes, 41 seconds. And that, where's my calculator? It has to be the last one. And that's how much it cost me if I have like the best grade, the cheapest one. So it cost me between $5 and $15 to run. Let me start, like, I don't need this anymore for now. And this one, I actually will go this way. Yeah, sorry. So it cost me around $5 to $15 to run one query to just know the number of rows that I have within this table. Okay? If I run the same thing in ClickHouse, it takes me 0.002 seconds. So 2 milliseconds. And this is what we use to like fill this here. Okay? So this is a query running where we get exactly this. And this is taking 4.41 seconds. Oh, this can be cached. Yeah, of course it can be cached, but it changes every single second because every single second you have a new insert that's changing that number. Okay, and then it's gonna take again 5 minutes to just run it the first time where you have it changed. There are some optimizations that are gonna happen in BigQuery. Yes, there are, but still 0.02 seconds, right? So let me show you another query. This is the top downloads by version. So the result is just like the version and the number of downloads we got. I executed this query, not very complex, like just requests project, specific project, the different versions for that project, select count, and it took about 9 seconds. And more than that, it actually cost me, oops, this is not updated. Yeah, that's not too much. Wow, the other one is way more. I thought this one was going to be a lot of money as well, but no, yeah, okay. So just running this query once cost me about, I don't know, 30 cents. But if you have people all around the world being able to run it whenever they want, you can run it right now when you access ClickPy. That's going to become a problem very, very, very quickly. If I run the same query in ClickHouse, this is a 0.009 seconds. So 9 milliseconds compared to 9 seconds. Let me show you my favorite. I was not expecting it to be, so I actually took some screenshots instead of having it open. So really, I wanted to know what was the minimum timestamp. So what is the first download? When did it happen? It took 5 minutes and 57 seconds to calculate when was the first download? Like, what is the first data point of my data set? It had to scan the whole 8 terabytes of data. And it cost me around $21. I did the calculation. In ClickHouse, it's not like blazing fast. It's not like a second query. No, it took me 90 seconds. This is 1 minute and 30 seconds. But again, that's not like 6 minutes to get the minimum value. Okay? It's like, this is a huge, huge difference. All right? So I think that kind of makes the point here. And just look, like we don't need to scan the entire data set because we're just looking for the mean timestamp. So we just need to scan that specific column, and that reduces a lot the amount of data we are actually scanning. It's not a row-oriented thing. It's a columnar-oriented database. So that speeds things up a lot for analytics use case. Okay? Yeah, so even that, like their cost is very complicated to understand. Like they actually they have an option that charges you by the amount of data that was read by the query. So it's like $5 a terabyte, which in this case would just be like $40 for this query, just for scanning all this data. So it's not straightforward to actually get the price of a query. And to make my point, you should not be worried about it, right? So yeah, let's bring it home. So there is a migrating from ClickHouse to BigQuery. I actually didn't have to do this because I have it somewhere else. This is the migration guide. I recommend you to read it if you're migrating now and want to know all the details. It's really helpful. What I did here was a summary of that. The labs are pretty nice as well. They kind of walk you through the ClickHouse part of things. So data types, primary key, like to really write some queries in ClickHouse so you get more familiar with ClickHouse if you're brand new. Why would you migrate? Data usage limitations, query latency, cost. ClickHouse is way faster. Okay, so if you're looking for real-time analytics and you have concurrent parallel queries, you're gonna cut your costs by a lot. If you're running ad hoc queries, don't move from BigQuery, okay? It's not gonna make sense. It's not gonna be necessarily way faster, and it is what it is. Prices, predictable, way cheaper. Again, if you have this use case of real-time analytics and a lot of people accessing your data. The most important part to me as I was doing research and putting all this content together is like data warehouses, they should encourage people to query their data, right? And like not the other way around. You should not be afraid of running this query. Like that was the query that I ran this morning. As I was looking into the time and everything, I was like, oh my God, like I have no idea how much this is gonna cost. And I was doing a lot of different things. So I saw something like this earlier, and instead of reading $5, I actually read $5,000 because we usually use comma as a separator, it's like not like the dot. And for the decimal. And I was like, oh boy, is it $5,000 just for a query for a training? So I was actually desperate for a second. I was like, no, it doesn't make any sense. And then okay, oof, that was not. So yeah, loading data from BigQuery is simple, like exporting to GCS. Like we had customers that did it and they said it was a smooth process. And you don't need to run the query yourself. That's something that I actually didn't show. In data sources, you can actually use click pipes, and you can just set your click pipe in here. And what it's going to do is it's going to be watching the bucket. So whenever something changes in the bucket, it's just going to import it. So you can set the click pipe once and just keep doing the other things and putting data in the bucket, and it's just going to keep ingesting all this data nonstop. Some important conceptual differences. So primary and foreign keys, they were added late in BigQuery. They used for performance within join queries. So still no guarantees in terms of primary and foreign keys, but they're definitely used to optimize joins. But there are some caveats, like primary keys, they must be unique, they cannot be null. Foreign keys, they must have values, they're present in the primary table, otherwise you just get wrong stuff. So you still need to take care of everything. It's just kind of a performance optimization. ClickHouse, no uniqueness, no referential integrity. Primary keys are the sort order of the data in disk for performance purposes. Cluster tables, so tables with a user-defined column sort order. So this is what our primary keys are. It's what cluster tables are in BigQuery. It's just an optimization technique that can improve query performance. In reading and trying to understand the way we implement it, it's actually slightly better, because if you have multiple columns in BigQuery, the first column must be present on the filter. Otherwise, it just ignores it. It's not our case. We are slightly smarter than that. Yeah, it's already built in. Materialized views, pre-computed views that periodically cache the results. It's used for smart tuning, fresh data. So BigQuery also has that, but it's only refreshed within 5 minutes and not more frequently than every 30 minutes. And if data is changing and like the throughput is just too high, I doubt BigQuery can keep up with it. We do have materialized view as an insert trigger. So it's just the insert trigger. It does not support updates and deletes. The defined query is executed on a new insert, is stored in the destination. Take a look into projections and refreshable materialized views if you're interested in more of this. Transactions, BigQuery is ACID, full compliance. ClickHouse does not. We kind of support limited transactions. We have this eventual consistency model. And if you send the same insert, we'll just figure it out and not duplicate stuff. We have workarounds. So if you're worried about transaction, read consistency, just take a look into those links in here. Partitions, almost the same thing. Views, aggregate functions, although ClickHouse has way more than BigQuery. So BigQuery has about 22, we have 150 plus the combinators, which allow you to do an if and like just combine things. Data sources, we have way more data sources than BigQuery, more than 90 different formats. Array functions, we do have a lot of support for arrays. And now with the new JSON data type, we also have great support for JSON. It's really fast and it improved a lot. If you heard about JSON and ClickHouse before as being not good, we released a new version of JSON and it's just really, really nice. With that, I want to say thank you all.